then they
Sure.
start interacting.
Exactly.
And then you get this branching, and the local branches are stable,
Yes.
relative to
Yeah.
non-local, which which are
Yeah.
not stable. But
Yeah.
this is you're talking about initial state of the universe, which is was not developed. This is, you start with some kind of a special state, which it was not special, which in the sense which is not correlated. It's very special, kind of. Most of states are correlated. So the state which is completely not correlated is very special.
Yes.
Well, out of this special one, you get many words.
Yes.
But after the evolution, and in your case, you need from the beginning to get special state.
No.
But no.
Why do you need that the initial state is uncorrelated, right? And then the correlations build up. Why do you say you need it?
No, but they will not build up. If there is no time, and this is the state of the universe, that this is not, nothing will happen. In this world, nothing will happen.
That's just because that state indicates the state at all times. The state I was showing, it's time independent because in a sense it has time inside.
Yeah.
Time is
So-
inside.
So, but then the evolution, there is no evolution which can create in this picture in which there is no time. There is no evolution which can
Just no
create,
evolution.
which can create this.
Yeah, okay.
So
It's like the block universe picture in general relativity. I mean, whatever block universe you choose, there's no evolution. I don't get your point. I don't see what you're saying. In general relativity, you have the same thing, right? Block universe, in which the time is it's just a coordinate. It has no
general
physical meaning.
relativity, I don't have picture. I don't know if anyone has picture.
No, I don't think so. But it's the same thing.
But it doesn't exist. So quantum there is no kind of attractive picture of quantum mechanics and relativity.
No, I agree.
The gravity.
But just
all
consider-
approaches which I hear sound
I
worse than GRW.
Sure, I agree.
So
But just think of general relativity without quantum mechanics. That's what I was talking about. There you have the block universe picture, in which the time is just a coordinate. It has no physical meaning, just because different observers see different times. So the only thing that has a meaning is the proper time of observers going around in space-time. So there's no evolution of the whole space-time. It's just there. And the picture I presented is basically the same thing. There's no evolution. It's just a whole thing.
I don't know. Gravity is geometry, but is it picture which kind of I don't know enough general relativity, so I took my course when in my graduate studies, and then I did touch it. So
Right. It's pretty fascinating theory, actually. I'm not an expert either, but yeah, but I've been studying it a little bit now for this project.
I think one of the big problems in general relativity is the problem of energy.
Okay.
Because you cannot bound the energy, and the space has energy. You cannot really define it, and at the same time it curves. So that's the
for me,
big mystery of general relativity.
for me, this was a solution of thermal death. This was written in Landau, and I kind of believed him. Because if you look on thermodynamics, then entropy goes up, and so why now we're not in equilibrium? And Landau said that we have there is this evolution, gravitation, cosmological evolution, so the space changes. So this is why we're not in equilibrium, because the space is not constant. The space evolving, and this is why there is no.
Why do you say we're not in equilibrium? We are. Almost all the degrees of freedom of the universe are in thermal equilibrium. almost all the degrees of freedom of the universe are. We are not, but
No.
we are not typical. The typical degree of freedom of the universe is a microwave photon from the Big Bang radiation, and that's in thermal equilibrium. Almost all
but
degrees.
we are not. So
We are not,
So
but-
then this is what should be explained. Because why?
Right.
Yes.
Yes. But when you say the universe is not in thermal equilibrium, it's almost in thermal equilibrium.
This is a statue, kind of interesting.
Yeah, there was a statue.
It was a rifle with this.
Okay, I didn't see it. You see McDonald's? We went there.
Yeah, I've been there.
Yeah.
There is McDonald's?
Yeah.
Just
we
with
have-
chicken burger.
Chicken burger.
Of
Only
course.
chicken burger. Or
There's
vegetables.
Kentucky fried chicken too.
That's right.
No.
You see? Here.
Ah,
Kentucky Fried Chicken.
I never could get those. Where are you from? Originally in
Leningrad.
Ah. I'm going to Georgia this winter.
Like Tbilisi or?
Yeah, I'm using this program Erasmus Plus, which pays for a week of. If you go to give a course in some place,
Yeah.
it pays for the trip and for a week stay. So I asked these guys in Tbilisi University, and they said, "Okay, why don't you come?"
Erasmus, and who is paying?
European Union.
Should you go to some kind of place, kind of Europe, or Georgia?
Well, yeah,
Georgia is
originally-
not considered as Europe.
Yeah, I know.
Europe.
Originally, it was only for Europe.
Yes.
But then they added a few countries outside Europe. One of the countries they added is Palestine, which of course you would say is not a country. Still, there is this possibility.
So you can go to Ariel University. It's in Palestine. Yeah.
Ariel University? Okay.
Yes. What?
There's a list of universities, so you cannot go
Anywhere.
But maybe this is on the list.
I don't think so. It's
No?
the Ariel University. It's really kind of settlement. It's Ariel is a Jewish country on territories, which is
Yes.
a Jewish city on the territory, and recently it became a university. Kind of, it's a big fuss if it's university or not.
In which region? In Cisjordania? Or?
It's between Tel Aviv and Jerusalem, kind of. But
there is some-
It's what's considered West Bank.
Anyways, they were happy. They said if you come in February, we're organizing a winter school, so maybe you can give your course during the winter school. So it won't be in